How are you guys? How are you? I am fine. In the previous discussion, we have seen that about arithmetic sequence. Today, we'll try to see about geometric sequence. Let us start to discuss about the geometric sequence. So let us define the definition of a geometric sequence. What types of sequences? What we call it geometric. So let us see here the definition. Here we have definition of geometric sequence. A geometric sequence. A geometric sequence is one in which the ratio between the consecutive two terms between the consecutive terms is n0 constant. So we say that such a type of sequence is what we call it geometric. This constant is called common ratio. That is what we call it the common ratio. That is here gn plus 1 over gn, which is equal to r. This implies that gn plus 1 is equal to gn times our common ratio r. Then we say that such a kind of sequence is what we call it geometric sequence. If gn is a geometric sequence, a geometric sequence with first term g1 and common ratio r, then the nth term is given by that is what we call it gn is equal to g1 r raised n minus 1. Now let us prove this one. Here in a geometric sequence, gn plus 1 over gn is equal to r. So based on the definition, the consecutive two terms, the ratio between the consecutive two terms is what? Our common ratio r. So if gn is a geometric progression or geometric sequence with first term g1 and common ratio r, then the nth term is given by gn is equal to g1 or the first term times r raised n minus 1. Now let us prove. Consider or let g1, g2, g3, g4, gn are terms of arithmetic sequence or arithmetic progression. Then we obtain that g2 over g1, g3 over g2, g4 over g3 is equal to gn plus 1 over gn is equal to our common ratio r. Now we have g2 over g1 is equal to r. This implies g2 is equal to g1 times r. And also g3 over g2 is equal to r. This implies g3 is equal to g2 times r. But what is g2? g1 times r. So g1 r times r. g1 r squared. g4 over g3 is equal to r. This implies g4 is equal to g3 times r. This one is equal to what? We have g1 r squared times r. So g1 r cubed. g5 over g4 we have r. So g5 is equal to g4 r. g1 r cubed times r. g1 r4. Now we have g2 is equal to from this G1 R, G3, G1 R square, G4, G1 R cube, G5, G1 R4, and also G6 we obtain G1 R5, and so on. So when you see this G1, 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 and here there is also G1, it is common. But the only difference here is that the exponent of R, when it is 2, we have 1. When it is 3, we have 2. When it is 4, we have 3. When it is 5, it is 4. When it is 6, we have 5. So when you change that, this 2, 3, 4, 5, 6 into n, we obtain that G1 R raised n minus 1. So in the geometric sequence, the nth terms of the sequence is G1 times R raised n minus 1, n minus 1. Now let us see an example. Example 1. If the first term of the sequence, is three and the common ratio 2, then find the first 5 terms. Okay, solution. So solution we have here, it is given G1, it is 3, R, it is 2. Now we are going to find the first 5 terms. We have G2. G2 is equal to G1 times R. So this one is equal to 2 times 3. We have 6. And G3 is equal to G1 R squared. So we have G1 3. Our R is 2 to the power of 2. So we have 12. G4 is from the formula G1 R cubed. So 3 times 2 cubed. So this one is equal to, so we have 3 times 8. 3 times 8, we have 24. G5, G1 R4. 3 times to the power 4. So this one is equal to 3 times 16, which is 48. Therefore, the first 5 terms are, that is G1 is 3. So 3, 2, 6, 12, 24, and 48. Those are what you call it, the first 5 terms of the given geometric sequence. Now let us see additional example. Example 2. If G3 is equal to 9 and G6 is equal to 2, 4, 3. G6 is equal to 2, 4, 3. Then find G1 and R. Now we have solution here. Given that is what? G3 is equal to G1 R squared, that is 9. And also G6 is equal to G1 R5 is equal to 2, 4, 3. This implies in order to get G1 and R, here we have 2 unknown variables. Now we are going to find G1 and the common ratio R. So G1 R squared 9. G1 R5, that is 2, 4, 3. Now we are going to find G1 and R. Now G1 R5 over G1 R squared is equal to 2, 4, 3 over 9. This implies this is cancelled by this one. So R raised 3 is equal to 2 to 27. So this implies R is equal to the cube roots of 27 is equal to 3. Here R is equal to 3. R is equal to 3. Now we are going to find G1. This implies from G3 is equal to 9. Here we have G1 R squared is equal to 9. So G1, we insert 3 in place of R. 3 squared is equal to 9. This implies G1 times 9 is equal to 9 over 9 over 9. This is cancelled. So G1 is equal to 1. Therefore, in the given geometry sequence, G1 and R, G1 is equal to 1 and R is equal to 3. R is equal to 3 based on the information which is given. And G3 is equal to 9 and G6 is equal to 243. So we can find G1 and G3 if it is also given in another question. So we can calculate based on this one. So thank you for watching. This is all about today's discussion. So I would invite you to subscribe, like and comment for this YouTube channel. Thank you very much for watching.